So hello everybody, my name is Erik Saluveer, and I just arrived from Estonia this morning. And I'm delighted to be on this event because it's about mobility, and I'm a big fan of mobility data, to be honest. And I'm going to talk to you today of what we are doing with mobility data in Estonia in a company where I work at. It's called Positium. Positium is a spin-off company from University of Tartu, so together with a research group, we mine big data sets and turn this kind of data into meaningful information. And I'm going to give you some examples how we do that. So, quick overview where I come from, maybe then it's better to understand how we do the things in Estonia. So Estonia is very small. In a sense, there's living only as many people as is the urban area of Copenhagen, so it's 1.3 million people together. Although the area is bigger than Denmark, which makes it very not densely populated, and maybe this is also the reason why Estonia has really turned into all sorts of e-services over these past 20 years, because if you are living in countryside, it's kind of hard to provide from the public institution services for the citizens. It's quite expensive. It's much easier to do them online. And Estonia now enjoys a lot of e-services. So, for example, these last elections that were taking place, 1/3 of the whole voters were voting electronically in Estonia. So only 2/3 went to the polling stations. And but there are a lot of different e-services that have been developed. And this e-service development has also pushed the people to ask even more and more e-services to come up with, or to substitute traditional methods with e-services because we are so used to it. And maybe this is also the reason why the thing that we are doing have happened. Also, one promotion for Estonia is that from next year, Estonia is going to provide access to Estonian e-services through e-resident form. So everybody actually in the world could apply for Estonian e-residents and become a new kind of 21st century citizenship, in a sense that you could use, for example, services in Estonia in order to establish a company in 10 minutes and then not going actually to the place. But yeah, you could follow the media for that. Anyways, the problem that Positium is trying to solve goes like this. So, for example, Estonia is also becoming very mobile because of these ICT solutions. It's much easier to live further and further away from the city centers because you have fast cars, better infrastructure, better public transportation. You could also work from home and so on. And now already 1/4 of Estonians are living or working outside their local municipality. And this, of course, raises a question for the all sorts of planners how to organize this kind of society. I just found out today morning an example of where this kind of society could go to, not really in Estonia, but in Beijing. They just made security checks for metro, and this is how it looks like. This is a picture from today. So you really have to develop in advance solutions not to end up like this. This kind of the problem is put into a concept called new mobilities paradigm, which means, like Carolina also said today morning, it's that humans are developing faster than the infrastructure. And also the planners need to go by that to make a faster decision to catch up the human development. And of course, to make this decision, you need really fast data. And not only the fast data, but the data also has to be as rich as possible, not only, for example, a small sample of people, and so on. So how is it possible to get fast mobility data? What are the possible data sources? And there's also this problem with traditional methods. So this is one example how traditional methods work. Here people are stopping cars on the road in order to ask them questions, where are you coming from and where are you going to? So feels kind of really not 21st century again. So how could you change this kind of approach? What are the possibilities? And also the problem is that on the other side, you need to engage with the citizens. And Misha Dollar from London King's College University discussed also on one of their talks that you actually all the cities and want to engage the citizens, but how can you perform that engagement? And he made a test. He went to the London street and tried to ask one simple question, whether the citizens are really satisfied with the public transportation in London, I think was the question. And he tried to ask 400 people who passed him by, but he was totally ignored, and he got only 3 answers out of 400. So these traditional methods really don't work. Maybe you also have been approached by a guy trying to ask you a question, and you are going like, no, no, no. So we need something new. What is this new? And we think that the new thing is mobile phone. Mobile phone is very special because nowadays people, if they leave home, they can leave at home credit card, they can leave home watch, they can leave home even their computer, but they never leave without mobile phone because it's so important. So everybody carries a sensor, and it's a good thing where you could start. And these sensors generate loads of data, and you could float on it. So you not only need the data, but also you need to know how to process the data in order to make it meaningful. Otherwise, you would end up like this. This is real mobility data from Estonia if you plot it as it comes in raw format. So this is what we do at Positium. We transform this data from mobile phones into meaningful information that could be used by different end users. What is mobile positioning that we use? Mobile positioning is a technique where you obtain location from the mobile devices. So you get the time and space parameters, and you use either device-based technologies or then network-side technologies. So at the background, you see transcripts of my billing information from my mobile operator, and you can see from there that I've been on 17th of January at 8 o'clock somewhere in Orange network, and actually all this information is also stored in any mobile operator network all over the world. And inside the country, you have these kind of data with good spatial resolution to be used for the purposes I mentioned previously. So this is the data we use. But in general, you could use mobile positioning into 2. There's active mobile positioning and passive mobile positioning. Active mobile positioning is where you make a program in order to derive the location information. You have to ask a permission from the user in order to get the location. And for example, you can build an Android application to derive GPS coordinates or Wi-Fi positioning or something like this. And you could also program some code to access mobile operator location services to pinpoint or triangulate the position of mobile phone. But you still need to ask a permission, and you need to program it in order to be worked. But today I'm more going to talk about passive positioning, which is where you actually don't need to program anything because data is already generated. It's somewhere in the server log files, and you obtain them from the log files. Of course, the data has to be anonymous in order to comply with privacy laws, but otherwise it's really a possible data source. And the data source, it could be, for example, this from the mobile operator, but more and more are other data sources coming up, like I'm going to talk also, for example, Endomondo data, or then Google or Facebook or all sorts of big companies already have huge loads of passive positioning data files lying in the servers. And in Positium, what we do is we put together different competencies in order to process the data. So you need to have this geoinformatical knowledge in order to process spatial data. You need to know what kind of models you apply on the data. You need to know the theories of society. So you need human geographers and social scientists. And in order to understand the end client who are using most probably this mobility information, you also need knowledge about tourist management, marketing, planning, and so on. And finally, to mix it all together, we also need to have a modeling knowledge. And this is what is the core competence in Positium in order to process that kind of data. And passive mobile positioning goes like this. So as majority of people have a phone and they are carrying it, if you do anything with a mobile phone, then the mobile phone interacts with mobile network. So these cell towers, and it is stored in the network operator log files that you interacted with this cell tower in that hour. And as you are using mobile data, for example, in your phone, then almost every second your mobile phone is interacting and it is all stored. It sounds a bit creepy, but it's really not, but okay. And then you can process this kind of historical data to make these kind of statistics I'm going to show you. In the raw format, for example, Estonia one day looks like this. So already making a very simple animation, you could see, so this is only the movement data, not the stationary data, but you could see how the rhythm in the country goes like. So the two big capitals, Tallinn and Tartu, are exchanging a lot of people, and then you could also see the other regions that drive up. But this is the kind of mobile positioning data plotted on simple animation. Hi. Okay, let it be. You may wonder how accurate it is. So how actually the positionings are derived. So I told you, as you are using mobile phone, it's connected to with a radio signal to an antenna, which is usually sticks to a site or mobile mast. And this mobile mast, of course, has somewhere X and Y coordinates that you can link together. So in very basic form, this mobile positioning data looks like this. So you have anonymous subscriber identity, then you have this cell identity, which is connected with X and Y. Then you have the time, and yep, this is very basic how the data looks like. But you have billions of rows of this kind of data. And because the planners are not really satisfied with this kind of accuracy level, because it could be from 100 meters to 10 kilometers, then our competencies again come into play. So we do a lot of different processes in order to answer our end users. So for example, we improve the positioning by probabilistic geographical distribution, which means that we use land cover data in order to estimate where the positioning could possibly happen, and also analyze the patterns over time. I'm not going to go really deep into that, but if somebody is interested, I could talk later. And we do a lot of different algorithms. I also don't have time to explain, like profiling the users on their patterns, interpolating, cleaning the data, and so on. And of course, we have to comply with the privacy directive. These are the directives from European Union that we have to comply with. But we are working together with the data protection agency in Estonia in order to really kind of have the approval that everything we do is really complied, and it's legal that we do. And then quickly the benefits of passive positioning before I go to the examples. So the main benefits of using passive positioning is that you get it really quickly. As I showed you this example of asking the question where the cars are going to, this is when people go to the road and ask the drivers. Usually it's made on paper, and it takes, like, I don't know, at least a week in order to get the data into digital form and to clean it. But this kind of passive mobile positioning could be stored from the log files almost real time. The main benefit, of course, is enormous quantitative sample. In Estonia, approximately 95% of people are using mobile phones, so basically you get like a sample of 90% of people from the country. It has the best coverage in the sense of space and time. You can't cover the whole country in any second without any other data sources besides the mobile positioning. And which is very good also is that the people themselves don't need to do anything. They are kind of passive sensors for this this kind of analysis. And it's very cost efficient, of course, because you need to do only programs, in a sense. You don't need to go outside to pay for the guys who are asking the questions on the street and so on. And now Positium is mining the data from all three mobile operators, so Teliasonera, Tele2, and Elisa. And the data is processed into 5 main domains where our end users are. So one is tourism statistics. So if you visit Estonia, don't be mind, you will be kind of added to the statistics. Then urban and regional planning, of course. Public transportation planning, which is kind of obvious, safety and security, and geomarketing. And this is example of the clients. As you can see from the names, it's mainly public sector who uses the data, which is also kind of obvious. So now I will show you some examples of the data. So the tourism statistic is one of the main products of our data. And I just plotted it's kind of actually old graph, but what you get is this tourist statistics over time, how it has changed over time. You get these profiles, like whether these tourists are one-day visitors or multi-day visitors and so on. And of course you get the then their origin or where they come from. So you could see, for example, on this plot, that 63% of, I don't remember where, the tourists were from Finland. Very simple statistics, very easy to make in a sense, but they are very valuable. So for example, one end user is the National Bank of Estonia, who uses our data because they need to calculate how much money tourists are bringing to the country and how much money the Estonians are taking out going as a tourist somewhere. And they used to rely on accommodation data and then also border control data. But as you know, within the Schengen area, you can't anymore get this data. And also because of the new kind of tourism, like you go to Airbnb or you just visit for one day or something like that, they can't catch these kind of statistics anymore. And this is why now already 3 or 4 years, the Bank of Estonia has used our data, and our state balance has been constituted on this kind of mobile positioning data. And you could already see that the citizens themselves benefit from it because the state balance is calculated more accurately than it would be with traditional data sources. So we have a kind of nice round where also the people who are kind of censor for the data, they get the benefit in order that the government is working more efficiently. Yes? Sorry? It's the Russian this union, what they have. I even don't remember what's... Yeah, it's the Russian union. And actually, now we are consulting also Eurostat, so most probably this kind of solution will also come to other countries. So at the moment, we are kind of unique in the world because there are some countries also who are using mobile positioning data, but not on that scale. So, and Eurostat is thinking that it's going to be the future, so we should actually apply it for other countries also. So at the moment, they are doing the feasibility study that we consult them also. But this was the easy statistical part that you can make. But of course, if you have the data, you could start doing a lot of other things, and we are inventing new things all the time. But one example is event detection. So if you have this temporal pattern of, for example, these Irish visitors in Estonia, you start to see the spikes in the data. And these spikes mean something usually. So what we do is, with algorithms, we mine the data, find the spikes, then mine all sorts of publicly available other data sources like cultural data sets, also Foursquare Open API, Twitter Open API, Eventful Open API, and try to guess what's going on there. And for example, in this case, we can see that it was one football match that took over 2,500 visitors to Estonia from Ireland. So it's very useful for in order to basically get the automatic overview what kind of events are happening in Estonia, and also as you get the event you detected from the database, you start to add some quantitative information to that event. For example, this Lindora fair in southern Estonia, which is a fair that nobody organizes, it's self-organizing, just people know a date when they come up there. We can extract from which region people are coming to this event, compare it with other events, for example, this golden fish in southern Estonia. Also see how many people came there, how many were tourists, foreign tourists, local tourists, and so on. These kind of quantitative statistics are possible to extract from mobile positioning data. And you could also go even further. For example, take one municipality and see how loyal are the tourists in different, for example, event type categories. So, for example, on this slide here, this municipality that we observe has most of the people who are repeating visitors on the sport event type. And this is very valuable again for example, helping up maybe the cultural events in order to make them also more loyal, or to bring their more loyal visitors, because the loyal visitors are the ones that everybody are seeking for, because as they come every year, it's guaranteed kind of income for this event. And for municipalities, we put these statistics into different graphs that they can follow over certain times, so they can monitor how well their different measures that they apply on tourism work. And we have different web applications for them. Also, for example, this map is for looking what are the main routes that tourists take in order to maybe make better marketing or cooperation with other municipalities. But besides tourism, the other important sector is public then planning, for example, regional planning. Here you can see main commuting patterns in Estonia. This data is used for organize or making a new plan for adding up different municipalities, because we do have them too many, and there's this ongoing discussion how we should do the regional reform in Estonia. A good data source for that. Or you could also study long-time migration patterns in Estonia, and then make measures, political planning measures on top of these. Or you could also take, for example, here we took one city district, wanted to see how many people are commuting to the city district in order to reorganize the whole transport in this city district area in North Tallinn. So with the green dots you see the people who commute to this area, and with red dots you see locals. So during the night you really don't even see the commuters, but then you could see like where they kind of aggregate the local people, and how could you reorganize the transport then in this area. The question was which road should be one way in this particular region. Or you could also do the analysis where to build, for example, where to build a retail shop, because you can see where people move. It should be somewhere where they are moving or where they are going or aggregating. But actually, in this case, we also once did active positioning experiment. This is an example of a Estonian art academy, which was demolished, and then the question was where to build the new house, because they needed a bigger one. So what we did is we tracked with this network-based active positioning on the consent a number of students and also the professors, in order to see how they move in the city. And based on these patterns, we saw what could be the possible kind of aggregating places for these people, so that the new building would be close to them. And it was useful because the city government proposed one building that was in suburbs, and it was already clear that the people don't have any connection with this area, so it would have generated totally new commuting into this area. So this idea was dropped, and now they are building into northern city center, where a lot of hipsters are living. And of course, transport planning. Transport planning is based on mobility, and in transport planning, one step is generating origin-destination matrices between different transportation zones, And this is what we provide for Estonian planners. So mobility from different transportation zones, how many people are going from one to another in different times. And for example, it has been used for different public transportation optimizing projects and also road planning projects. Or also you could monitor where to build a new infrastructure. So there was a question of a new railway to plan to Estonia. So we looked how the different regions in Estonia were connected with this southern part of Estonia. Or also, for example, just monitor how many people are going through some city area as a transit, because you can extract who are locals and who are not. So this is was used for making this roundabout over the city, and they wanted to know from where to where people are making the transit. You get this kind of map. Or also to give different priorities for transportation. For example, there's one project going on in Chile now, also on this mobile positioning data in Santiago, Chile to Santiago, that to see where the car beats the metro and where's the other way around. So in order to make city priorities for the public transportation, one possibility also. And yeah, on active positioning also, we did this where do you bike. So as you wanted to, we wanted to map the biking routes that people make, or the city government wanted to, and we built them these solutions that they send an SMS first, start the positioning, then through the network we positioned these people, and they send the end message as they finish their road, and finally got the map of the biking routes, how people make. But it was already, I think, 4 years ago or something like that, and we now have much better possibilities, and this is why I end up with another data source that we've put our hands on now is Endomondo data. So Endomondo data is, well, you know most probably what Endomondo is. It's a tracking platform for mobile devices, and it's organizing every year European Cycling Challenge in May, so it's going on now. And it's very simple. So cities put up themselves for the competition, then the people choose their city, they join the challenge, then they download the app, track the journeys, and these are then stored in the database. So 2012 there was only 7 cities, and this year 32 cities, and we've been analyzing 2012 and 2013 data in Tallinn. This year 32 cities from Sweden. The bigger ones are Uppsala and Umeå, I think, but unfortunately not Malmö. But maybe next year then. And Tallinn really joined the challenge in order to analyze the data, because as there is increasing number of cyclists, they have to make investments into bike roads, but they have no idea where should they be. So they need some data to make the priorities. And this is why the Tallinn city government promoted the event in order to get more and more people to participate and show where they are biking. And then data from 2012 and 2013 were analyzed. And you get these very basic statistics So for example, this is the whole May month, 2012 and 2013 compared. And you could of course see them by time, by different weekdays. So already discovered that people really don't use bikes during the weekends. The city government actually thought that it's mostly used on weekends. And also, this is the pattern during the weekends, and this is the pattern during the weekdays. So it's already, you can see the different variations. Or you could see the different speeds. So the blue one is 2012, and you can see that 2013 people already moved a bit faster. And actually, the effect is from the new roads, because during 1 year, they built quite a lot of new bicycle roads, and they really already raised the cycling speed inside the Tallinn as a general number. And then, of course, the distance to the speed, you could see that the longer distances people make, the faster they go as an average, and all sorts of statistics. Or also what kind of city districts are connected by bicycle roads. So, for example, Lilleküla, Kalamaja, which are the two main hipster regions, are the most popular ones also, so covering different city districts. And they can see the change that, for example, this Kalamaja is now the biggest biker ones. And also the one reason is, again, because they got the new bicycle roads in order to connect them with new areas. So you could already see the effect from the data. And then we generated a load of maps. So for example, you could see the trip time in minutes in different regions, the trip length. All these maps are kind of obvious, although you already, for the city planners, it's still important to see these small aspects in the data. So for example, within the city districts, they see that it's more used. Okay, yeah, I skipped that. Or yeah, average speed, for example. Average speed is interesting. You could see from the data, from GPS data, how really the sideways and then the main roads are used on different speeds, which of course makes sense. But for example, as they built a new cycling road here, the people moved from this main road to the new biking road at the speed even grew bigger than they were on the main road. This kind of observation the city government could make. And from the average speed also, you could see where are the problematic places where the speeds go really down. It means intersections where bicyclists have to wait, for example. So you could detect from the data. And also the destination map. So in order to maybe plan the public parking spaces or organize the bike sharing program that they are thinking now about. And quickly, that's about it. I end up with the animation of this Tallinn Cyclist. One day, how the day looks like. And yes, thank you for listening.